Okay, welcome back to our discussion on joins. So I went ahead and I wrote the SQL code for our two tables. And so before I run that SQL file, I need to create a database. So let me just quickly create a database. Okay, so I am the Postgres user. I will create a database named, let's call it week 4. So week 4. And let's connect to week 4. Okay, and then I'm just gonna create a user, and the user will be named week 4. Okay, and I'll keep the password as my usual password. Okay, so I have my week 4 user with my week 4 database. So I'll exit \q, and then I will log in as a regular user. So PSQL -- host is localhost -- db name is week 4 -- username is week 4. Okay. Right. So I am the regular user and I've logged in. Do I have any tables? Nope, no tables. So notice that this is the file I want. Okay. So again, make sure before you start up Postgres, make sure you're in the same directory where the file you want to run is located. Okay, so let me just open up Visual Studio Code so that I could show you the code that I wrote. Okay, again, none of the code that you will see should be strange to you. There might be one or two new keywords, but that's what I'll explain. Okay, Visual Studio seems to be taking a bit of time to load. Okay, so let's give it a couple seconds. Okay, so let me open. Okay, great. So this is my first table. Okay, we have the ID, the first name, the last name, and we're going to drop this table if it already exists. Okay, remember we always say that. Now what's new is this cascade. Okay, and this cascade I'll talk about later. Okay, now I have my second table name address. Okay, an address will have the ID, the name of the address, and we have our student ID column. Now, how do we tell Postgres that this column, student ID, actually is the same ID on line 8? Right? Because remember, we need a way to link up these two tables. And we said that we want to link them based on the ID, right? Okay, so all you have to do to tell Postgres that this student ID is the same as this ID is to say student ID, right, which is integer. Oops, Actually, it's not integer. It should be serial. Okay. Oh, actually, let me take that back. It is integer. Okay. All right. So student ID, which is of type integer, and this is it. References. This is the word that you must understand. References. Okay, this word simply is telling Postgres what comes next is how I link these two tables. So Postgres, whenever you see student ID, please know that that is referring to the student table. Okay, so I have the student table. So you write the name of the table, and inside parentheses you say which column, ID. So when Postgres sees this, it says, oh, okay, student ID just means ID here. The student table, ID column. So that's what the references means, okay? And I'm gonna just mention this on delete cascade, okay? I'll come back to it, okay? I'll come back to this, just like I will come back to this one, okay? So those are my two tables. Again, I have to have this references section here, right? All this references says is, here is the name of a column, and this column actually should match with this column, okay? All right. So remember, we need a way to link them back together, and that's what this references keyword does. So student ID is the foreign key, okay? So the foreign key is just the one that allows us to link back to this original table. So I will put a dot here and say this is the parent table, okay? And then this one we're gonna call this is the child table, okay? Okay. So once I have my two tables created, I will simply go ahead and insert values into my student table. All we need is a first name and a last name, right? And then I'm going to insert into my address table the address and who the address belongs to. I won't put the name, I'll just put the primary key, okay? I'll put the primary key, okay? So we know that Jane Smith will be primary key 1, and we know that Jim Smarts will have primary key 2, right? Because we know that when we use the serial keyword, serial start at 1, and then it increments by 1, okay? So the first record will be 1, the second record will be 2, the third record will be 3, and so on. Okay. So I have two addresses for Jane, and I have one address for ID 2, which is Jim. And then here I have my simple query, okay, which we looked at. All right, then let me just, oops, let me comment this delete for now, okay. Okay, all right, so this is my, and I'll provide this to you so that you can run it. All right, and so I will simply run this. So here, right, \I student info.sql. Okay, right? So we have, this is the query. This is the query. Okay, So let's say select, and by the way, I noticed some of you are doing your queries like this. Select all from student. Okay, I don't want to see this kind of query. Okay, I mentioned when you do a select query, you should have the select and the from on two separate lines. All right, they do produce the same result, but one is easier to read. Okay, okay, and then select all from address. Okay, so of course when I run the query puts them back together, right? So 2 rows for Jane Smith because Jane Smith has 2 rows, and then 1 row for Jim Smarts. So the principal can just look at this report and say, oh, okay, Jane Smith, 2 rows. Jim Smart, 1 address. Okay, that's what you use the joins for. The joins are used to produce a report. Okay, produce a report. And to produce the report, you have to bring the tables back together. All right, so again, these values here, 1, 1, 2, refer to these values here, 1, 2. So notice something. These values never repeat. So in the parent table, they never repeat. That's why they call it parent table. But in the child table, they can repeat. Okay? And that's why they call it the child table. Right? Just if you think about it, a uh, parent, parents can have many children, right? Can have many children, right? And so if you have 6 siblings, right, and all of you share the same parent, then if I had to put you in a database, you would have all 6 of you belonging to the same parent. All right. So the key thing now to take away is this. Let me say it again. Let me read it. This is an example of a one-to-many relationship in a database. The one table, which is the student, which I call a parent, can have many rows, meaning the ID can be found many times. Okay, so that's what I mean. So the one table can have many rows in the many table. This simply means a student can have many addresses. Okay, so this is a one-to-many relationship, which is one of the most common relationships in databases. Most things have a one-to-many relationships. Okay, most things. A parent has many children, a student takes many courses, a teacher teaches many courses, a hospital has many nurses, a hospital has many doctors, a hospital has many patients, patients has many illnesses, um, a home has many doors, a home has many rooms, all right? That sort of thing. So it's very common to have a one-to-many relationship. Okay, so let's talk about this on delete cascade. What does this mean? Okay, well, this brings me to this uh, um, delete statement. If I want to delete a row, then I say delete from, and then I say where. So let's say I want to delete, okay, let's say Jane is no longer a student at our school. So I want to delete Jane. So if I delete Jane, I want all the addresses belonging to Jane to be deleted, right? Since I don't want to keep track of her anymore. She's not a part of our school. All right. So how do I do that? Well, I will simply say delete. All right. Okay. I'm gonna say from. All right. what's the name of my table? Student. Okay, where the ID is 1. Okay, so ID is 1. So when I do that, okay, it deleted it. So let's check my student again. So notice Jane is gone. Let's now look at the address table. What do you notice? All those addresses that were belonging to Jane are also gone. So how is it that the database knew to delete everything from the child table when the parent gets deleted? Well, that's where this command on delete cascade comes from. So when you put this beside the foreign key, right? Beside the foreign key, right? So foreign key references. When you put that at the end on delete cascade, it simply means that if you delete some row from the parent table, in our case the student table, then any rows in the child table, so any rows in the address table that belongs to that parent or has the same ID as that parent should also be deleted. That's what the cascade means. So undelete cascade. So you delete the parent, search the child table, and delete all relevant rows. All right, that's what the undelete cascade means. Okay, so that's good. Now, what does this cascade mean? Well, if I don't put this cascade, okay, let's see what happens. Okay. So it tells me, it says, you cannot drop the student table. You cannot drop the parent table. You cannot delete everything in the parent table and delete the table because there is objects that depend on it. What does that mean? It simply means that there is still an address that is linking back to the student table. And if you delete the table, notice I didn't say delete the row 2. If you delete the table, then this table will become inconsistent because when I look and say 2, what does 2 mean? Let me check the parent table. Well, the parent table doesn't exist anymore. I deleted it. So now these children are basically orphans. I have no idea what the 2 means. So the DBMS is preventing me from making that from that happening. So we don't want any orphans. All right. So to tell the DBMS that, guess what? I want to delete this table, but also make sure you delete everything that is linked to this table. And to do that, you say cascade. Okay. And so this cascade will say, okay, let me delete student. Anything attached to student? Yes. Student ID references this student table. So let me drop everything from this table and delete it. Okay, delete this table. So now let's run the command again. See, now it wait a minute. It allows me, right? So drop cascade to constraint. Yes, all right. So this is just telling me that, you know what? You dropped a table that had a link. So you're just notifying me. Okay, it didn't stop it. It just told me that, guess what? You dropped a table that had a child. Okay. So once again, we will see that we have the same things. And then if I check the address table, I have back my original, and I have back my original, right? Okay, so to recap, whenever we want to have a one-to-many relationship, we split, the tables are split, okay? So if you notice that you have one big table and your big table talks about different things, 2 or 3 different things, then you have to split those tables up, all right? And so this is a one-to-many relationship, right? One-to-many relationship. Okay, so this is how we delete a row. Okay. All right, so I hope that makes sense. So once again, it's just an extension of what we learned in the last lesson, in last week's lesson, where we looked at joins. All right. So in this lesson, I wanted to show you the whole reason why we need joins. So again, you should recognize that this is a one-to-many relationship, meaning that the values in the parent will never repeat. However, the values in the child will repeat. Okay, and you can clearly see that here, where this is the parent. Okay, the IDs never repeat, but when you come into the child, you notice the IDs can repeat, which makes sense, right? All you're saying is this ID, which belongs to some person, can come 2 times, which simply means this person has 2 addresses. All right. Okay. So again, that's the reason why we call it a many, one-to-many. The IDs can never repeat. They can only be one of them. But in the child table, the IDs can repeat, so you can have many of them. Yeah, I think I've exhausted the ways of saying that. Okay, so one-to-many. Parent one, child many. The key of the parent, the primary key of the parent, goes into the child table. Again, the key of the parent goes into the child table, and then it's called a foreign key. That's how you create the link from the one to the many side. Okay, you get practice in doing this for your quiz, because I realize that just listening to me talk is only half of the story. When you actually have a problem to solve, then that's where your mind turns on. So that's it for this lesson, and I will see you in the next one.